Welcome to Learning to Engineer. In the previous video, we have solved a circuit with a dependent current source by applying KCL. I have explained you step by step how to solve a circuit when the dependent source is 0.8 Ix. Now, in this video, I am just going to replace the source by 0.8 Iy and I am going to solve it for you. If you have not solved that circuit, click the link in the description or here and then proceed with watching this video. Find the voltage, current and hence the power absorbed by the circuit elements if the dependent current source is 0.8 Iy. Iy is this current which is the sum of 5 ampere plus the current through 10 millisiemen. We have seen that 10 millisiemen is 100 ohm, 1 by 10 millisiemen is 100 and 1 by 40 millisiemen is 25 ohm. Siemen is the unit of conductivity which is 1 by resistivity. We are assuming that the current through this resistor is from this direction and the current through this resistor is in this direction. The voltage at this node, let us say this is VA and the voltage at this node, let us say it is VB. Iy is 5 ampere plus the current through this resistor. We are considering the direction from A to B. The voltage at this node is VA and the voltage at this node is VB. And the current is from B to A here. Basically the current flows from a higher potential to a lower potential. But in these both resistors we have considered in the reverse way. If B has higher potential, the current direction should be from B to A in both the resistors. If A is higher, the current direction should be A to B in both the resistors. We do not know which has a higher potential. So let us say in this example, we considered two resistors with currents in both directions. Later on, when we apply the law of power conservation to solve the circuit, we will get a much better idea about the current direction in both the resistors 100 ohm and the 40 ohm. So this is the plus terminal for this resistor and this is the minus terminal for this resistor. By KCL, Iy is 5 ampere plus VAB or let us say minus VBA, because even in the previous circuit we considered the voltage B to be greater and now we are going to add these currents. So we are assuming that the current is from A to B in this circuit. So let us consider the voltage to be minus VBA. Minus VBA divided by the resistance 100 ohm. Current is voltage by resistance according to Ohm's law. So this current is the voltage across this divided by the resistance 100 ohm. Iy is 5 minus VBA by 100. Let us have this aside and let us solve for Iy in this node. Iy is, because 0.8 Iy is flowing into this node, so that is why it is Ix minus 0.8 Iy. So this implies that 1.8 Iy is Ix. What is Ix? Ix is VBA divided by 25. So this is VBA divided by 25. So this implies that Iy is VBA divided by 25 into 1 by 1.8. If I solve, I'm getting VBA by 45. So we have two equations basically. This is one and this is one. When I equate Iy in both the cases, I will be able to get the value of VBA. Here 5 minus VBA by 100 equal to VBA divided by 45. This implies instead of taking LCM and solving for this, I have another method. What I usually do is I just substitute it by 1 by 45 is 0.0222 plus this is 0.01 into VBA. So we will get VBA as 5 divided by the sum of these two, which is 155.17 volt. VBA is this. Let us find Iy. Iy is 5 minus. In this circuit, we have IY as 3.44 and VBA as 155.17. It is always better to find all the circuit elements, current and the voltage, and then verify law of power conservation. This will get us a better idea about the circuit, and we will be really able to see through the current and the voltage that is across each and every element present in the circuit. We have a 5 ampere source, 100 ohm resistor, 40 ohm resistor, and then 0.8 IY source. The power that is supplied by this is 5 times the voltage VBA. By the VBA we are considering this as positive and this as negative. So VBA is 155.17. Across the 40 ohm resistor, it is again VBA square divided by 25. I'm sorry, this is 40 millisiemens or 25 ohm. This is not 40 ohm, this is 25 ohm, which is here we have the sources 5 ampere and 0.8 IY that are supplying current, and the resistors 100 ohm and 25 ohm are absorbing current. So let us find the sum of absorbed currents and supplied currents. Let me say PABS as the absorbed power. It is the power absorbed is 1023.886 watt, and the power supplied will be 1203.87. The absorbed power is 1203.886 watt and the supplied power is 1203.87 watt. Maybe if you calculate the approximated value, it will be same. The reason why we have a minute difference between these two is that while performing the calculation, we have approximated for the value of VBA, and even here we have approximated for the value of the power absorbed by this resistor and this resistor. Even in IY we have approximated the value. The value is 3.448 something, but we considered only the first 3 digits. So by considering all these approximations, we have a minute difference between the power supplied and the power absorbed. From the next week, I am announcing the Solve With Me series of videos where I will be solving the important problems of the circuit theory paper, which will be useful for your university exams or for your GATE or for interview or any kind of a competitive exam that you are going to write. There will be no explanation provided. There is an exciting reason behind it. We really learn when we try to solve a problem. Instead of going behind the books, reading the theory over and over and over again, we can solve a problem, test our knowledge. If we don't get the concept right, we won't be able to solve the problem, right? So you have to solve the problem in order to understand. Don't worry, you won't be alone. I'm going to solve the problem along with you. Without any explanations, I will just be solving the problems. You can pause the video as and when it is required, solve it by your own self, and then come back to the video to check the method. If you have a better method than I am showing you here, please post that in the comment section by just take a photo of your solution and then send me. I will be happy to post it in my next coming videos.